before we get started with today's lesson, we're going to look at problem number 8. They tell us point A is 3, 3. Point B is 3, 9. Or not 3, 9, 6, 9. And point C is 6, negative 3. And we're wanting to determine or classify it by its sides and then determine whether it is a right triangle or not. So in a coordinate grid, so we have 1, 2, 3. 3, 3 would be about here. 5, 6, 7, 8, 9 would be about right here. And then 6, negative 3 would be about right here. So we would have this here. Now, if we did this on the coordinate plane, on the coordinate grid, we would have been able to see that the distance from B to C, points B to C, would be along a straight line, and we could have counted straight down. 9 and 3, this would have been 12, or we can use the distance formula to find the same thing. So we would subtract our x values from B to C, which would have been 6 minus 6 squared, plus we would also subtract the y values, which would be 9 minus negative 3. Well, 6 minus 6 is 0. Negative and negative would make a positive. So 9 plus 3 is 12. 12 squared is 144. And the square root of 144 is, so the distance from B to C is 12. Now we'll need to do the same thing from A to B and A to C. Now the distance formula for A to B, so we would have 3 minus 6 squared plus 3 minus 9 squared. Now 3 minus 6 squared would be negative 3 squared. 3 minus 9 squared would be negative 6 squared. Now 3 squared is 9. 6 squared would be 36, which would give us the square root of 45, or 3 square root of 5. Okay.
I just want to talk to you.
Okay. Now, for any of these distance formulas, we could have typed these straight into the calculator and actually gotten the answer as well. Now, the last one we need to do is find the distance formula from A to C, which would be 6 minus 3 squared plus negative 3 minus 3 squared. Now, 6 minus 3 is going to be 3. 3 minus negative 3 is going to be negative 6 squared. Now 3 squared is 9. Negative 6 squared is 36. And 9 plus 36 would give us 45, or 3 square root of 5. So we can see here that we do have two sides that are congruent, so it would be an isosceles triangle. Now point A would be the point where most likely the right angle would be if there was going to be a right angle. So we just need to find the slopes of AB and AC. And if they are opposite reciprocals, then it is a right triangle. So the slope from A to B, we would subtract the y value. So y 9 minus 3 over 6 minus 3. Well, 9 minus 3 is 6 over 3, which is 2. A to C, we would do the same thing. So A to C, we could say 6 minus 3 over negative 3 minus 3. Well, 6 minus 3 is 3. Negative 3 minus 3 is negative 6, which gives us negative 1/2. Well, 2 and negative 1/2 are opposite reciprocals of each other. So this would be a right isosceles triangle or isosceles right triangle. So it would be a right triangle. Any other questions on this here? Number 10 would be the same thing as this here. If we can hit it tomorrow, or if we do have time after the lesson, I will hit it then. I do want to make sure that we do have time to look at what we're doing today. Now, what we're doing today will take a good bit of class time, but it's not overly complicated. Interior and exterior angles. Interior or where?
Inside.
So their angles inside. Exterior is? Interior angles are going to be angles inside the figure. Exterior angles are going to be angles that are? Almost. The first theorem we're looking at is the triangle sum theorem. The sum of the interior angles of a triangle add up to be? What? The sum of the interior angles of a triangle will add together to be? Okay. So what do these three angles add together to be? So if we take x plus 47 plus 58, this should equal
65.
Guys? Yes? Yeah. Because we're going to, if we add those two together, this would be 105. And if we subtract 105 from 180, we get 75. If we have subtracted 58 from 180 and then 47 from 180, we would get 75 as well. So the value of x is 75. Because when we add all three angles together, it should equal 180. So we started off by adding 47 and 58 together, combined like terms, which gave us 105. We subtracted it from both sides, and we found out that the missing angle, or the value of x, is 75. Now, how can we classify this angle, or triangle, based off its angles? So each one of these angles are what? So this is an acute, because an acute triangle has all three angles less than 90 degrees. A right triangle has how many right angles? And an obtuse triangle has one obtuse angle.
What's the one with 3 then?
Equiangular. Any other questions on this here, guys? Let's look at this one here. Well, we do know that all three angles will add together to be. Now, we could add those two angles together and subtract from 180. Early, we can say that x plus 96 plus 21 is equal to 180, because the sum of the interior angles of any triangle will add together to be. Now, we can add our like terms, 96 and 21, which would be? And then what can we do? Subtract 117 from? That's what we did. Because we added them together and? Yeah, that's the exact same thing. Now, how can we classify this triangle by its angles? Because we have one angle that is greater than 90, it's going to be an obtuse triangle. Any other questions on this one here? We ready for the next one? I feel like we feel comfortable with these here, yes?
Not the next one.
What do we know about any three angles inside of a triangle? They add up to be what? 180, yes? Because the sum of any three interior angles of a triangle add together to be 180. So if I add these three angles together, so if I add 2x plus x minus 6 plus the other one is? This will equal, because the sum of any three angles in a triangle will always add together to be 180. Okay? Well, what are our like terms? If not, yes. Well, if I have 2x plus x, I have a total of? What is negative 6 plus 90?
Negative 84.
Now we need to get x by itself. Since we have plus 84, we would do the opposite operation, which would be subtraction. Because 84 minus 84 is 0, leaving us with just 3x. 96. Since we have 3 times x is equal to 96, we want x by itself. We would divide both sides by 3.
32.
And this problem here was asking for the value of x. Find the measure of each acute. We have to plug it back in.
Okay, so 2 times 32.
Well, it's asking you to do 2 times 32, which is?
64.
So one of the angles is?
64 degrees. And then 32 minus 6 would equal 27. No. 26. 6 1 off.
So all we had to do was solve for the value of x and then just plug it back in.
This one our triangle is actually easy to do. To explain better.
Any questions on any of this here? This one here, now we have 3 expressions with variables, yes? But what do? They all add together to be. So we can say 3x minus 17 plus x plus 40 plus 2x minus 5 is equal to. Well, here we have 3 expressions with variables. Now, we can combine our like terms first, since we have 3 different spots where x is on the same side of the equal sign. We can combine those. We can add them or subtract them. 3x plus x plus 2x. Well, 3 plus 1 plus 2.
Does it always have to be 3 in order to add them together like that?
No, it's just because they're on the same side of the equal sign.
Oh, okay.
Since they're all on the same side, we just combine them. The only reason we have to do the opposite operation is if we're trying to move it from one side to the other. Now we can do the same thing with negative 17, 40, and negative 5. We can just add those. So we can do that in a calculator. Now, we want to get 6x by itself, so we're starting to move stuff across. Minus 18. So 6x is equal to So it asked for the value of x, yes? Did the instructions ask for anything else?
No.
And so we do need to know the values, yes? Well, one of them is x plus 40. Well, x is what? 27 plus 40 is... So one of the angles is 67 degrees, which would... I'm just putting it there so we can see it. We could do 3 times 27 minus 17. Well, again, we could step it out or we can just type it in. 64 total. And 2 times 27 minus 5 would be 49, yeah. That makes, that is too big. It would be 49. So how would we classify this triangle based off its angles? It would be acute. Is there any of the angles greater than 90 or equal to? So this is an acute triangle. Any questions on this here? Now the next thing we're looking at is the triangle corollary to the triangle sum theorem. Corollaries are just something that comes from the actual theorem itself. And what this says is the acute angles of a right triangle are complementary. Complementary angles add up to be 90, yes? So let's say this here, because it's one thing to have it told to you. Let's actually look at this. So if we had two angles, angle A plus the measure of angle B, plus 90 is equal to 180, because three angles inside of a triangle always add together to be 180. If it's a right triangle, well, we know one of them has to be 90 degrees. Well, if I'm trying to find A and B, I mean, I could subtract 90 from both sides, because these would cancel, leaving me with just the measure of angle A plus the measure of angle B. Well, what is 180 minus 90? So, I mean, they could be 45 and 45, or they really could be any two angles that add together to be 90. Well, let's look back at this here, because we did this problem already, yes? So we went through and solved, but it is a right triangle, yes? What do these two angles add together to be? So instead of solving it set up like this here, we could have done the same thing, but just had this equal to 90, and we would have gotten the same thing. So if we look at this problem here, we do have a right triangle, yes? Because we do have one right angle. So what that's telling us is that these two angles here will add together to be 90. So we could say that 2x minus 2 plus x plus 5 is equal to, could we have added all three together and set it equal to 180? Would it give us the same answer? Mm-hmm.
You just take away that equal sign.
And then set that equal to 180. Do we have any like terms? 2x plus x is? Negative 2 plus 5 is?
Minus 3 on both sides, divided by 3, and then 90 equals 30, or x equals 30.
Okay, so we subtracted 3 from both sides.
Oh, never mind.
Sure.
Am I allowed to?
I'll duck to the shackle for later.
Or do you want me to just figure it or what?
I'll put it up here. I'll
Whatever. It's the end of the day, but
yeah. Just I'll talk with her and then we'll make a decision.
okay. Sorry, I got back from the field trip. I didn't realize it. Okay.
We'll make a decision and let you know.
Went off.
Okay. Now, classify the triangle by its angles. Well, what would this triangle? Well, what does it have? So this is a right triangle because it has one right angle. If a triangle has one right angle, then it is a right triangle. Well, since it already told us we had one right angle, it has to be a right triangle. Any other questions on this here? This here is the last theorem we're actually looking at today. The measure of an exterior angle is equal to the sum of the opposite two interior angles. Now, looking at this here, I'm going to call the interior angle there next to angle 1, angle 2. Now, we do know that the sum of any three interior angles plus angle C, B, plus the measure of angle 2 would be 180, because C does have two angles. It has that exterior and the interior, because we did that at the start. Now, angles 1 and 2 make a straight line, yes? So we could say also that the measure of angle 2 plus the measure of angle 1 is equal to. So the sum of the interior angles is 180. The sum of angle 1 and 2 is also 180, yes? So could we set these two equal to each other? Because they're both equal to 180. So that means I could say that the measure of angle A plus the measure of angle B plus the measure of angle 2 is really equal to the measure of angle 2 plus the measure of angle 1. This is, I'm just showing you how this works. Now, do they both share measure of angle 2? I mean, I could subtract it from both sides. Here would cancel, this would cancel, really just telling me that the measure of angle A is equal to the measure of angle. So the sum of A and B is equal to the measure of angle 1, the exterior angle. Well, let's see where they're located. So these two angles here are equal to the sum of the opposite two interior angles is equal to the exterior angle. The exterior angle is equal to the sum of the opposite two interior angles. So whatever this measure is will be the same as these two added together. So when we look at this here, this angle x is going to equal the sum of the opposite two interior angles. So x is equal to what? Yeah, 21 plus 34, and 21 plus 34 is 55 degrees, because the exterior angle is equal to the sum of the opposite two interior angles. The exterior angle, the one outside, is always going to equal the opposite two interior angles, the sum of the opposite two interior angles. Yep, because it's just asking for x. Yep. Questions on this here? Yes. Because according to the theorem, the exterior angle, which is 122, is equal to the sum of the opposite two interior angles. Well, one of those interior angles is x, and the other is? So to get x by itself, we would 90 from both sides. Well, these would cancel, leaving x by itself. And that's it. Questions on this here? We're ready for the next one. We'll see. So the exterior angle is what? And it's equal to the sum of the opposite two interior angles. One of the interior angles is what? And the other opposite interior angle is? Because 3 and 51 are both like terms, yes? If we add them together, we would get. Now we want to get x by itself. So we would subtract 54 from both sides. These would cancel, leaving us with. And then we would divide by 2. Exactly, x is equal to. And that's it. Questions on this here? Let's look at one more. Would you all want to look at 17 or 3? So if we look at 3, because I think 3 is a little bit more challenging. So it's on the very last page. Now, any 3 angles, so the 3 angles inside of a triangle add up to be 180. Do we know anything about the measure of angle 1? No, we just know we need to find it, yes?
Yes.
So I can't define it as x because the actual 3x, that's x, and it may not be the same. So we can't do that. But what we just saw was that the exterior angle is equal to the sum of the opposite two interior angles. Yes, sir?
Okay, that line that goes out past the triangle, is that part of the triangle?
It is, we extended one of the side lengths out to form an exterior angle, to make an exterior angle. But we do know that the exterior angle is equal to the sum of the opposite two interior angles. So for us here, 5x minus 10 would equal what? Sum of the opposite two interior angles. But if we could find the value of x and plug it back in, then we can solve for the measure of angle 1. So, are there any like terms on either side? Because 5x and 3x are like terms, yes? Are they on the same side of the equal sign? No. So, and the 10 and 40 are, but they're on opposite sides of the. So we need to actually go on and start solving for x and get x on the same side. We can add 10 to both sides or add 10 to 40. Negative 10 plus 10 would cancel out and give us 5x is equal to 3x plus. Yes, guys. Then we would subtract 3x from both sides, because we need to get x on the same side. 5x minus 3x is 2x is equal to 50. And then dividing by 2 will tell us x is equal to 25. Now to find the measure of angle 1, we need to plug it back in. So we can plug it in at 3x, because 3 times 25 would be 75. Now we do know that 75 plus 40 plus the measure of angle 1 would equal. So the measure of angle 1 plus 40 plus 75 is equal to. And 40 plus 75 would be 115, then we would minus 115. It tells us that the measure of angle 1 is
We should have just done 80 minus 15.
Any other questions on this here? Because we could have gone and found out what this is here, which would be 115, and subtracted it from 180 and got the same answer. Any other questions on anything we've done so far? That is all we are doing today. Yes. Yes.
For the homework yesterday, was it all? When it said 3 to 10, all, because that's all.
Yep.
Yeah, dude, that's what I heard. And I was like, bro, let's go. Right here. It's cool. It's going to college. I'll know. That's so. Let's see what major it is. For some of them. My parents. My parents went to college. Yeah, I've never done graduate. Just must graduate from that. But it's not a whole lot to go out past.
All right, guys. Do y'all want to still look at problem number 10? Yes. Logan? Guys? Yes. When Lily gets back. Guys? Guys? We're going to look at problem number 10 on the homework. Problem number 10 for the homework, we need to figure out the distances of all three sidelines to be able to classify it. So we can go from A to B and C. So for our first distance, we can find this measure here. So our x values would be -2 minus 3 squared plus 3 minus -2 squared. Now at this point here, we could plug this entire thing into the calculator and it would actually give us the answer. Now if we did this by hand, -2 minus 3 would be -5 squared plus 5 squared. Now -5 squared would give us 25. 5 squared would give us 25. This here would be the square root of 50 or 2 square root, or 5 square root of 2. Would be this distance here. Now we would need to do this again to find the distance from here to here. So our distance formula would be equal to -2 minus 0 squared plus 3 minus -3 squared. Now if we did this by hand, -2 minus 0 would be -2 squared. 3 minus -3, the 3 negative and negative make a positive, which 3 plus 3 would be 6. Now -2 squared would be 4. 6 squared would be 36, and 4 plus 36 would be 40, which would actually work out to 2 square root of 10. And again, most of these distance formula calculations, the calculator would do it 100% for you. You wouldn't actually have to do these by hand. And then the last one. Our last side length would be from here to here. So we have distance is equal to the square root of 3 minus 0 squared plus negative 2 minus negative 3 squared. Nice. 3 minus 0 would just be 3 squared. Here, the negative and negative make a positive, giving us negative 2 plus 3, which would just be 1 squared. 3 squared would be 9. 1 squared would be 1. Would just give us the square root of 10. Well, since none of the side lengths are the same, this would be a scalene triangle. Now, the next thing we need to look at or determine is if it is a right triangle. And especially if we used graph paper, we would see that if there's a right angle, it would occur down here, because that's the most likely place where it does look like it could be 90 degrees. So we can look at the two slopes. From negative 2, 3 to 0, 3. So we'd have negative 3 minus 3 and 0 minus negative 2. Well, 3 minus 3, yeah, negative 3 minus 3. It's not right. Negative 3 minus 3 would be negative 6. Negative negative would make a positive 2. So this here would be negative 3. Yes, the next one would need to be positive 1/3. So our other slope that we're looking at is right here. So we would have negative 2 minus negative 3 over 3 minus 0. Well, the negative and negative would make a positive. So this would be a scalene right triangle. And that's all we would need to do for this one here. Questions on this here?